Hello and welcome to the day 4 lecture for Upward Bound Advanced Math. Today we're talking about, we're going to start talking about functions. It's going to be a huge focus that we have throughout the rest of the program. And really what we're looking at here is just like I said, it does say basics of functions. I really am looking at the pure basics. Okay. I do want you to think of and put something in for yourself what you think a function is, or how do you visualize a function in math? Because I really think that visualizations are key to understanding any concept, really, but sort of math in particular. I'm going to try that again. Try to get something that looks a little bit better. So this is just kind of the visualization that I have of a function. Doesn't have to be what you think or anything like that. But I think of it as this machine, and I'm kind of looking old school a little bit. But I think of this machine as having like a turn crank. So this thing's going to go around and around. And it's centered right there. So the idea of a function, and maybe it's better if I put this. This just looks a little too linear for me. Maybe if I think of it this way. Great drawing, great artistic ability there. But I think of having some sort of numbers or items that I'm putting into the function, turning the crank, and then I get my outputs. Okay, and that's one visualization, one idea of what a function is. Kind of the working definition that I'd like to come up with, and I think in class we're going to sort of piece together our own function, our own definition, but kind of the most basic one that I like to use is just that it's a special relationship where each input has an output. So for everything that you put in, you get something out. That's the main idea of the function, is that I'm going to put something in, I'm going to get something out. Okay. And again, I think of it as this kind of crank machine, and I've got to spin the machine to make it spit something out for me. It's sad to say, I kind of think of like a meat grinder, if you've ever used a meat grinder before, especially a hand cranking one. So I'm putting in like a steak, and I'm getting hamburger out, so to speak. There's 4 ways to talk about a function. There's 4 ways to represent it. You can do it verbally. You can talk about how something changes, and this is a great example here. And all these are written in terms of the kind of temperature function from Celsius to Fahrenheit. So the idea is to convert Celsius to Fahrenheit and multiply the Celsius temperature by 9/5 and then add 32. Okay, you can do it algebraically using a formula, which is just kind of that elementary process of seeing what is written, taking a verbal expression and turning it into an algebraic equation. You can look at it visually. You can look at a graph. This is a function. Okay, it's a function of, over here we have our our Celsius temperatures, and the y-axis is our Fahrenheit temperatures. So this is Celsius, Fahrenheit. Or you can use the table of values, and this is more of a case-by-case basis, I guess you would say, more of an individualized account as to what happens. Included in this numerically is just that if you just wanted to pick one, and I wanted to know, what's 15 degrees Celsius in terms of Fahrenheit, that would be numerically looking at one individual one. So for the next thing I want to do is I want to look at evaluating functions. Again, somewhat of a, I'm not going to say an easy topic, but somewhat of a more elementary topic. Some of the earlier things that you probably did in math classes. And it just means to plug in the value of x and see what happens to get y. And I have those in single quote marks because it's not always x and y. In fact, most of the time in early classes, I guess it is, but it quickly becomes your input and output. So for this first row, I want to find all the g's. I want to find g of 1, g of 5, and g of -3. On the bottom, I want to find my f's. So g, the rule for g, the function rule for g is it's negative t squared plus 4t. Okay, my input is t, my output is g of t. So if I'm plugging in 1 squared is 1, negative of that is -1. So I have -1 plus 4 times 1 is 4, and we get 3. For 5, g of 5, I'm going to square 5, that's 25. Multiplied by -1, I get -25. And add 4 times 5, which is 20. So we get a value of -5. Next one, I'm plugging in a -3. -3 squared is 9. Times -1 is -9. And then plus 4 times -3, which is -12. And I get -21. Now, I know this seems like a pretty simple process for this being advanced math, and it is. But the idea is this can always be done. I had the sad fact of going through high school with just a TI-30. It's a calculator. It doesn't graph things. And in some of my advanced classes, a lot of my peers had graphing calculators, and they could graph things. They could look at different curves. I didn't have that capability, and it was kind of before all the graphing calculators came out on computers, at least the easy to use ones. And so I didn't really have the ability to see what something looked like. Obviously, we have that technology now, and we can make the most of it. But even if you can't, even if you just want to get a basic idea, this gives me the basic idea that somehow on this graph at -3, it's -21, so it's somewhere way down here. At 1, it's 3. And at 5, it's -5, so it's probably somewhere down here. So I just know that somehow this graph follows this kind of shape. And good job hitting that point. I just know that it starts going up and then it goes down. And there may be more things that it does, but for my limited view of it, I'm going from -3 to 5, I know it goes from low to high to low. Again, there may be more things there, and I just have to try other points to figure out what happens. And obviously, there's a lot of specifics in here. I mean, this thing could realistically turn even more times than that in this window. I mean, it could come here, drop down, come back up to here, drop back down through here, and obviously there's a lot of possibilities, but I know that as kind of a general idea is that it starts low, goes to some upper value, and it ends low, at least again in the window that I'm looking at. All right, looking at the next one, I have 3 raised to the power. 3 raised to the power of x. So this is going to be 3 to the third, which is 27. It's going to be 3 to the negative first, which is 1/3. And this is going to be 3 to the 0, which is 1. So just in what I know, and again, I'm only going from -1 to 3, but I know that this graph somehow at -1, it's 1/3. At 0, it's 1. And at 3, so not very far away from that, all the way up here somewhere 27. I mean, 27 is probably like up here somewhere. So I know that this graph gets pretty steep pretty quick. And again, there could be some other things that happen in there, but I wasn't worried about that right now. Maybe I'll look at it a little closer once I see that, just to see if that trend is continued or what have you. For function operations, we can add, subtract, multiply, and divide functions just like we do with numbers, and we're going to do that. So for this first one, I'm looking at f plus g of x. The interesting thing about these problems is I do have to note which functions I'm using. With addition, all that I'm looking at doing is going, this is the same thing as saying, go ahead and take f of x and add it to g of x, which will be 2x plus 1 plus, and you can put parentheses if you want to. G of x is 4x squared minus 3. So what do we get out of that? What are we accomplishing here? Well, I just have a polynomial. I've got one set of like terms. I've got the plus 1 and the minus 3. The other ones are just going to stay there. I've got 4x squared plus 2x, and it's going to be plus 4. And that's f plus g of x. Subtraction is about the same thing. I'm using some different functions here. So I should, note that. Actually, I'm going to switch colors because they're right next to each other. I am going to get f of x minus h of x. It's helpful to write it this way because then I'm just going to take what f of x is, write that down here. I'm going to subtract what h of x is, negative 3x plus 10. And then the only tricky part is that there's the subtraction in the middle, so I do have to distribute. So that's going to be plus 3x minus 10. And I have a couple sets of like terms here. It's going to be 5x minus 9. And that's what I get for that one. Multiplication, it is the same, and I keep saying the same thing, and what I mean is that you can write it as g of x times h of x. You can split this statement into these two, and that's helpful, again, because now I can write what g of x is, 4x squared minus 3, and multiply that by h of x, negative 3x plus 10. So this one I have to distribute, or I have to FOIL. Not really. It is distribute, but we nickname it FOIL. So 4 times negative 3 is negative 12. X squared times x is x to the third. 4x times 10 is 4x squared times 10 is 40x squared. Negative 3 times negative 3x is positive 9x. And negative 3 times 10 is negative 30. The interesting part about foiling this one is that I don't have any like terms. That is my answer. And last but not least, I have a division problem. I'm going to write it down here in blue. It is f of x divided by g of x. And more often than not, there's not as much that we can do when we divide, but let's go ahead and look at it. I have 2x plus 1 divided by 4x squared minus 3. And there's really nothing I can do there. There's no simplification that needs to be done. Now, most math classes do want you to simplify these, but just know that in practice, it's not required. And what I mean by saying it's not required, if I wanted to find this f plus g of x, but I wanted to say evaluate it, let's say at 5. I want to figure out what its value is at 5. I don't have to have this form of it. I can plug in 5 to this one here and go 2 times 5 plus 1, and that's going to be added to 4 times, not x, oh dang it, 4 times 5 squared minus 3. Now this will get a little bit tricky. That one's 11, not equals, that's a plus. That's 25, 197. And so, and I went a little bit quick there. I think I did it right though. Excuse me. And so that's going to be 108. And if everything's right, if everything was done right, if I plug it in here, I should get the same thing. 4 times 5 squared plus 2 times 5 plus 4. Sorry, that's 118. And that makes a little more sense. Oh, and I did that wrong. Okay. Now it's making even more sense. And was it 118 or was it 108? It was 108. Tried to fix a wrong and made it another wrong. This would actually be a minus 2. Yeah. Minus 2. Good job. It's fun to find mistakes and fix them. But it is important to know that, I mean, obviously I'm making mistakes. Everybody makes mistakes, especially when they try to go fast. So we've got 100 plus 10 minus 2, which is 108. So again, all I'm saying is that in practice, it doesn't really matter that you can combine like terms, you know, and do this part of it. It would be enough. And even like in this multiplication problem, if I tried to do the same thing, it would be enough to just know this part right here, okay? Because you could plug in your value of x into each one of these, and sometimes it may even be easier. I would say in this one, this is easier. It's not as straightforward and it's not as repeatable, but it's easy to figure out one value. All right. So now what I want to look at is composition of functions. And it basically means to take one function and plug it into another one. Okay. So we're going to do that. So in order to look at the first one, this says f composed with g of x. And numerically or algebraically, I guess what that means is I'm going to take f, I'm going to find the value of f of g of x. And what that means I really want to do is figure out what g of x is, which I probably know, but then put that as the input. And that's, again, going back to kind of what these parentheses mean. What's inside the parentheses is my input of the function. So even though f of x is 2x plus 1, I don't care about x itself. I'm going to take g of x. So I'm going to take this g of x and plug it in to the x in f of x. So I'm going to say that this is going to be 2 times 4x squared minus 3 plus 1. So this is the act of composing two functions. I'm putting one function in as the input in another function. And realistically, this isn't that bad. It sounds bad and it looks difficult. The order does matter. And when I say the order matters, what that means is f of g of x is not always equal to g of f of x. Okay, not always equal to. It can be, but it usually is in boring problems. So here I've got 2 times 4x squared. That's going to be 8x squared. 2 times negative 3 is negative 6 plus 1. It's going to give me 8x squared minus 5. Okay. And that's my answer. So that's my new function. I've just created a new function out of old ones. It's not that much more interesting, but you know, it's got a little flair to it. Again, it is helpful to think of this as, like, I think of the composition symbol, which is just a small open circle. I think of that as the word of. Okay, I think of that as the word of, meaning that this says g of h of x. Okay, so I'm going to take h of x and I'm going to plug it in as the x in g. So this one's going to be, I guess, a little bit complicated. We've got negative 3x plus 10, and we're actually going to square that and then subtract 3. Again, what comes first in order of operations? The squaring does. And so to look at that idea, I guess I can just do it here. The one thing that I want to make sure we do know is, this is always my fun conversation, that squared is not 9x plus 100. Okay? Here's the worst part, is you're going to see those numbers, but there's also something else. Okay? What this actually means is it means negative 3x plus 10 times itself. And so we've got negative 3 times negative 3 is 9. So that's going to be a 9x squared. Yeah, I guess usually you'd say that's x squared. So 9x squared, negative 3 times 10 is negative 30x. 10 times negative 3x is another negative 30x. So we have a negative 60x in there. And then we have our plus 100. Told you this problem was a little bit more interesting. It definitely is. Now I'm multiplying all this by 4, distributive property. 36x squared minus 240x plus 400 minus 3. And so the only thing I have to deal with is the minus 3. minus 240x plus 397. Okay, and that's my answer there. Again, kind of an ugly answer. And in practice, if I was trying to find one value, maybe it wouldn't be the best idea to do it, but most math classes ask you not just to do this. I mean, if you argued that all the time, then this would be your answer, and you'd say, look, I'm done. I composed it, and you did. But a lot of times they want to see a little bit more, and they want you to get to this level. I would almost argue that in this problem, in this particular problem, this part is easier. This simplified answer is easier. Okay. All right, let's look at h composed with f of x. So I'm going to take h, and where the x is, I'm going to put f of x. This one will be a little bit easier. What made the other one a little bit difficult was the squared on the outer function. The g had an x squared. That made life a little bit tricky. So I'm going to take f of x and put it in for x and h. So h is -3. And then I'm going to put my f of x. And this plus 10 or even this -3 or this plus 1, that's the most often missed part of any of these problems. Because students get done with well, I put that thing in, I put that function in, and they think they're done there. So please don't forget that other part. So just doing some, combining like terms, a little bit of distributive property. It wasn't too bad, but I get -6x plus 7. And last but not least, we're going to go with g of f of x. G is, dang it, I did it again, didn't I? We're going to put that f of x in there, that 2x minus 1. Sorry, 2x plus 1. We're going to square that, and then we subtract 3. So I'm going to do the quick version of this. And if you don't know it, I suggest you sort of think about it. When I square a binomial, okay, we call them perfect square binomials. It's always the first thing squared, and by the first thing I mean all of 2x. So I square 2 and square x. So that's 4x squared. The first one times the second one times 2. So 2x times 1 times 2. Well, that's just going to be a 4x. And then the second one squared, the second term squared. 1 squared is 1. Okay. Let's go ahead and distribute it now. So I've got 16x squared plus 16x plus 4 minus 3. And so I just have to combine like terms. And there we go. All right, we've got a couple problems bringing it all together. In class, I'm sure we probably won't go over all these, but I do like to go over all of them when I'm doing the video, just because I feel like sometimes students will go back and check their work on some answers. So f minus g of 10. So this bringing it all together involves the function operations and the evaluating of functions. So first I'm just going to deal with it in terms of x. I'm going to look at, well, what is f of x minus g of x? And that one's actually not too bad. F of x is 3x minus 1. And then we're going to subtract negative 4x. So subtracting negatives like adding a positive. So I've got 3x and 4x. That's 7x minus 1. Now I just want to figure that out at 10. I want 10 to be my input. Instead of x, I want 10. So I'm looking at 7 times 10 minus 1. 70 minus 1, we get 69. Okay, the next one, a little bit tougher. I've got a couple things to do, and I do kind of want to go in order. So I'm going to start off by finding f of x plus h of x, and then I'm going to compose that with g. So let's go and look at f of x plus h of x. That's going to be 3x minus 1 plus 2x squared plus 3x. And I can tell you that this is going to get a little bit tricky because of that squared in there. And by a little bit tricky, I mean a lot of bit tricky. We have 2x squared. It'd be easier if one of these was a minus, but it's not, so okay. We've got plus 6x minus 1. Yeah, I think that's all right. And so now that I have that, I want to compose that with g. So I'm going to take g of x, and I'm going to put that in wherever I see an x. That's a little bit better because g of x, I guess, is not a binomial. So negative 4x, square that, plus 6 times negative 4x minus 1. That was kind of our saving grace, that g of x was a little bit on the easier side. We got negative 8. Oh, no, I don't. No, I don't. Nice try. I have to square that first one. So that's 16, and that's x squared. So that's going to be 32x squared. That's going to be minus 24x and minus 1. That's as simple as that goes, but I want to evaluate it at negative 3. So now I want to put a negative 3 in wherever I see an x. And sorry, I'm trying to speed up a little bit. So I've got 9 times 32. I don't know off the top of my head. 288. So that's going to be a positive 288. And then 24 times negative 3. Some people are probably, that's going to be a negative 72. So negative 24, negative 72, or yeah, whatever. That's going to be a positive 72 in the long run. And then I have minus 1. Just to double check, 288 plus 72 is 360, so I have 359. Okay. Let's try to get these done. Just looking at just more examples. I do encourage you at any time to, if this is your first time watching it, like you weren't in class, go ahead and pause the video and do these. And then just check your work. So g of x minus h of x, I'm going to skip some notation a little bit. 4x minus 2x squared plus 3x. So let's see, that's going to be negative 2x squared. Negative 3x, negative 4x is negative 7x. Okay, and then I want to add on g of x. So I'm going to add add on f of x. And that's going to be 3x minus 1. And that's just going to affect that part. So we have negative 2x squared minus 4x minus 1. Evaluating that at 6. Let's go ahead and move that down a little ways. Evaluating that at 6, I have negative 2 times 6 squared minus 4 times 6 minus 1. 6 squared is 36. Negative 2 times 36 is negative 72. Minus 24 minus 1. So that's 96. Or no. Whoa, wait. Yeah, negative 96, negative 97. I did try to do that a little bit quick. There may be a mistake there, but it's just a computational mistake. And one thing that I really try to push is I look for more procedural mistakes rather than computational mistakes. And that just means I'm looking more at, can you do the basics of the idea of the problem right? Like on this first part, I'm looking, can we compose these two functions? Okay, f and g, so I'm going to take, f and h. I'm going to take h and plug it in for x and f. A lot of letters there. I don't know where I was going with that. 2x squared plus 3x. So 3 times x, this is my x, and minus 1. So let's see, that's going to be 6x squared plus 9x minus 1. And then I want to subtract in front of that, I want to go g of x minus that. So I'm going to go g of x minus all this. So let's see, that's going to be negative 6x squared. Trying to write it in descending order. That's going to be a negative 9, so that'll be a negative 13x and a positive 1. I believe so. Evaluating that at 2 squared minus 13 times 2 plus 1. I'm going to get 4, negative 24, negative 26 plus 1. So that's going to be negative 50, and negative 50 plus 1 will be negative 49. And that's our answer there. All right, so hopefully, I know that video went a little bit longer. Odds are, a lot of times the videos are going to go a little bit longer than the time that we spend talking about these in class. And that's not just to encourage you to make it to class. That's more that in class I'm probably going to do like half the problems that I did here. You know, just trying to feel out time, because we also spend time on the daily task, and usually that's about 15 minutes worth. So just want you to, you know, if you want to know the answers to the problems that we didn't do in class, I think that's a great strategy. It's a great way to see if you're getting it. There's also these problems at the bottom, and at least for now, I don't have answer keys for those. It's just something that if you want to work on, you can. And if you do those and want to know if you got them right, that's where I'd have you email me and ask me if they look good. Other than that, you know, great job getting through. We're through day 4 and on to bigger, better, and brighter stuff. Have a good day. We'll see you in class.